This is our October Guitar Guys hot rod guitar. It's a Fender Candy Apple Red Strat body, a Fender 50s reissue neck, and we're going to put a gold anodized pickguard on it, and we'll wire it up with some kind of cool wiring, and we're not sure of the pickups yet, maybe Fralin, and we'll put a Callahan bridge on it and vintage style tuners, and we'll show some of that process here so you can get an idea of what's involved with putting together one of these guitars. These necks are really nice. This is a genuine Fender neck made in Corona. Now they have necks available that are made in Ensenada, Mexico, and necks that are made in Corona. The Corona ones, of course, are more expensive. This one has the vintage style 21 frets, but it has a flatter fretboard radius than a vintage radius. It's a 9.5 rather than 7.25 inch fretboard radius, and it's got bigger fret wire than the vintage style wire. So those are the two most commonly requested deviations from vintage on a vintage style neck. So Fender did a pretty good job, I think, of coming up with the options for this neck. This body is made in Ensenada. Fender currently only offers Strat bodies and Tele bodies in 3 colors each. The Strat is available in Candy Apple Red and in black and in 3-tone sunburst. This guitar we decided to go with the gold anodized pickguard. We just thought it looked cool. Of course it'll look cooler once the pickguard's out of the package. And we thought that this would kind of pick up some of the gold that's sprayed underneath the body. If you don't know about Candy Apple Red, Candy Apple Red uses a metallic gold or a metallic silver undercoat, and then a somewhat transparent red top coat, so that you see a little bit of the undercoat coming through. And we think this gold pickguard will kind of pick up the gold in the body, and we just think it looks cool. So that's the guitar for this month. Here you get a better idea what the body looks like with the pickguard on and a bridge in place. I know we're going to get some comments from people that think we should put gold hardware on this guitar, but we don't stock gold hardware. I don't like gold hardware. Callahan doesn't make parts in gold with gold plating, so it's going to be nickel. We want to wait to drill the holes for the pickguard until we get the neck mounted and confirm the bridge location. The bridge is pretty much where it's going to go right now, but we'll put screws in it to locate it so we know for sure. The reason you don't want to drill the screw holes first for the bridge is because you don't want it to be a little bit off like this. If you see the gap around the bridge, if you mount the bridge and mount the neck, then that will locate this end of the pickguard, and then you can move the pickguard so that it's perfectly centered on this opening, tape it into place, and then carefully drill the mounting holes in the body. And so we're going to do it in that order. We got really lucky on this neck pocket. Right out of the box, the neck went down into the neck pocket on the body with no work required at all, and that is very often not the case. Generally speaking, this is a really tight fit, and if you force it in, you can crack the body here. You can get chips of finish coming away, and so often, you know, when these are fresh wood, before they put finish on the neck or the body, the pieces will go right together. But once they finish the neck and then they finish the body, sometimes a little finish will kind of roll over the edges of the neck pocket, and you need to get in there with a little sandpaper and a block and kind of work at it until you can get the neck to go in there. You want a snug fit, but you don't want to have to put a lot of force on it. This one went right in. It's perfect. It's sitting here with no screws in it, and so that's going to give us our location for the pickguard at this end. I'm going to screw the bridge in place with 2 screws, so we'll have that finally located, and we will have, or in its final position, we'll put the pickguard on and then tape the pickguard in place so we can go drill the holes in the pickguard. Here's a little trick that you might not be aware of. The first time a screw goes into the body, especially for the neck plate screws, where you're screwing a fairly large screw into maple, which is a hard wood. but also in this case where we're going to mount the bridge. The first time you put these screws in, a little trick is to get a little wax. This just comes from the grocery stores for canning, candle making, and many other uses like guitar assembly. And you just take the screw and get a little bit of wax on it, and that will sort of lubricate the screw as it goes into place so that it doesn't require as much force. Now I know people are going to be going, oh my God, look, he's getting a power tool next to that guitar, but I'm a professional. Same thing on this one. And with the wax, the screws go right in, no problem at all. Now, ordinarily, I might put screws and a neck plate on the guitar at this point, but this neck fits so snugly into the pocket that it's good as it is. It locates the front edge of the pickguard. We even up the gap here, and then we'll put tape here and here so that the pickguard can't move while we drill it. Okay, now we'll take the neck off and the bridge off, and we'll go to the drill press and drill the 11 perimeter holes for the pickguard. So we're set up at the drill press. I think you can see this even though I've got this light kind of positioned where it obscures some of the action, but you should be able to see down here. So we've checked the diameter of the screw. It's 113 thousandths. So we selected a number 39 drill bit, which is 99 thousandths. You don't need much thread engagement on these pickguard screws. In fact, on a lot of old guitars, half of the pickguard screw holes are stripped, but they still, the screws still hold the pickguard on. So really, you just don't need that much. So we've set the depth stop on the drill press so it can't go too deep. And what we're going to do now is just go around the perimeter of the thing one at a time and visually center the drill press in the opening on the pickguard. Now we have got this piece of thick leather on the drill press table to protect the back of the body, and we'll just start with this hole right here. Okay, so I obscured this screw hole with the tape, but I could see its outline well enough to get the screw hole located. So that should be 11 screw holes, and we're ready at this point. Now, since we have the drill press set up for this operation, we'll also do the jack plate now so that we don't have to set this back up again in the future. With a Strat jack plate, you want the tip connection to go straight down. You don't want the jack mounted in like that or rotated in this position. You want that tip contact to go straight down. And here we have a lock washer on the inside between the jack and the jack plate, and then on the outside we have a flat washer followed by the nut. Now of course this is just finger tight. We'll tighten it up before we build the guitar. So essentially this is going to go straight in here like this, and you're going to butt it up against this edge. So push it as far as it'll go in that direction, and then just bring it back slightly, maybe a 1/16 of an inch, and that will be fine. Hold it in position there, and we'll tape it down and drill through the holes just like we did on the pickguard. Let me just say one other thing while I'm thinking about it. You don't want to leave masking tape on guitars. When we taped the pickguard onto that body just now and drilled the pickguard holes, the tape was on there for maybe 30 minutes or so, and then we got it off of there. The crepe pattern that's on part of masking tape that's in the paper can imprint onto guitar finishes. And if it does, the only way to get it out is to sand it and buff it out. So you don't want to leave masking tape on bodies. Definitely a bad idea. We have a couple more quick processes. Now some people will notice that we didn't drill holes on the back for the back cover plate, and that's because we're not going to put a back cover plate on this. A lot of people just leave them off, and so we're just not even going to drill holes for one. Personally, I don't like them on there, and so we're not going to put one on there. Now we just pulled this off the drill press. If we put screws into these holes, these pickguard screws, then we run the risk of chipping the lacquer here. So I'm just going to take a countersink by hand and just kind of lightly countersink those. Just takes a couple of minutes. It's easier to control this by hand than if you put this thing in a drill and do it. We're going to install tuners on this neck. These are the tuners that we're going to use. These are Fender tuners that says made in Japan, and that tells me that these are Goto. Sometimes they'll say made in Korea, but if they say made in Japan, they're Goto. And Fender has two versions of these. These say Fender down the center, and there's another version that doesn't say Fender down the center. The first thing that we need to do is to install these bushings in the face of the headstock. Now, I was a little surprised to find that while Fender did counterbore these holes for these bushings, and you can actually press them down in there pretty well, you can't get them to seat because they're just a little too shallow. They need to be deepened just slightly. To find out what size hole they used, I used these transfer punches. You could use drill bits if you needed to. Most people are probably not going to have transfer punches, but these are in a set that goes up by 64ths of an inch, so you can find just the right one. This is 11/32, and it goes in the holes. This is 23/64, and it will just barely start, but you can't get it to go down in the hole. So that tells me that 11/32 is the way to go, and so we're going to put an 11/32 drill bit in the drill press, and we'll just slightly deepen these counterbores so that we can press these bushings down in. In fact, I'll probably go a 64th of an inch under 11/32 because it seems to me that these are going in a little too easily. I want them to press into place, and these I can push in with my finger like that, which means that they're more likely to fall out. So that last little bit that we're going to counterbore we'll do slightly undersized, which will force these to be pressed into place, and they should stay put a little bit better. So it occurred to me that some people might be surprised that these holes wouldn't just be right out of the box. Oftentimes with guitar parts, things don't line up or fit exactly as you expect them to, and every guitar tech knows that often you just have to make things fit. I think that comes as a surprise to consumers, so don't be surprised if you get into a project like this, if the occasional little thing comes up that you have to sort of tweak to make everything work properly. Now my technique on this, I've drilled a couple of these holes. I'm using a 21/64 drill bit, and even though it's smaller than the counterbore that already exists, I run the risk when I plunge the bit down of hitting the edge of one of these holes and potentially chipping the finish. So I'm going to do them one at a time, and the first thing I do is I'm kind of holding this on the other side of where I normally would. Ordinarily I'd be here, but I don't want to block the camera view. So I'm going to do it with the drill press off, and then I'm going to press firmly with my hand. If I release with my hand, the neck will do that, and I don't want that. I want it firmly pressed against the table. I'm going to line it up first, hold it there firmly while I turn on the drill press. And that way I know that when I plunge the drill bit, it's going to go straight into the hole and not hit the edge and risk finish damage. Well, I did exactly what I didn't want to do. When I was drilling the very next hole, I didn't have the thing pressed firmly enough against the drill press table. The drill bit grabbed the wood, pulled it up from behind, and it chipped out a little bit of it here. Fortunately, it will be hidden by the tuner and it causes no mechanical shortcoming, but it was a lesson learned. I've learned that lesson before, and it bit me again. So I've drilled out the other two, and I've test fit one of the bushings, and it fits perfectly. So now we'll press in the other 5, and I'll show you how we do that. Anytime you need to press something into a hole, you're safer to use a press or some method that you can control the insertion rather than tapping on it with a hammer. Of course, in a pinch, you know, you can tap on it with a hammer. A plastic mallet is better in a case like this probably than a metal hammer, but nothing beats a press. And if you don't have a press, and most people don't, you can use a drill press. You can chuck something like a rod into the chuck of the drill press and use that to press it into place. But it just gives a much more controlled way to force something in, and it makes it very quick and easy to do in a way that you're not going to damage anything. Fender packages these vintage style tuners in these cardboard boxes and with masking tape to kind of hold them in place, and it puts a little masking tape residue. So I'm just using a little naphtha on a paper towel to clean that sticky tape residue off. That way it won't end up congealing on there or hardening over the years. And also, because the screws for these tuners are so tiny, Fender gives you slotted in Phillips head. We'll use Phillips head. But because they're so tiny and because you're going into maple, again, we'll use wax on them. And now I'm just putting the tuners on here. This is Phillips screws that I've used a little bit of wax on them. Just get a little bit of wax in the threads, kind of roll it in like that, and screw them into place. Nothing to it. Just be sure and use the correct size Phillips screwdriver. Some people don't realize that if you have the correct size Phillips screwdriver, there will be no play at all between the screw and the screwdriver. When you stick it in there, there will be no play whatsoever. And that's your assurance that you're using the right size Phillips screwdriver. I've seen a lot of people use screwdrivers that are smaller than the size that should be used. So why do we shield a guitar? Here we have a Strat body, and it's got normal routing, and then we've got a Strat pickguard. This one happens to be metal. Most of the time they're not. Most of the time they're made of plastic, but they'll usually, at least from Fender, have a foil shield, so you've got a metal layer attached to the back of the pickguard. The idea with shielding is that if we take the electronics that are carrying signal, right, the pickups, the pots, the switch, and if we enclose that circuitry inside a conductive box, and we connect that box to ground, then that box will act as sort of a force field, and it will intercept stray sources of hum and prevent that hum from entering the signal path. So this is the lid to our box, our conductive box, the pickguard. The box is the cavity itself. So if this lid and the box are both conductive, electrically conductive, and if those things are connected to ground, then sources of EMI and RFI can't get into our signal. EMI and RFI, EMI stands for electromagnetic interference, and RFI stands for radio frequency interference. And there are lots of sources for these in our modern world, and they will get into your signal and come through your amplifier. So that's the concept here. We're creating a box around the electronics and connecting the box to ground. Now understand that when we talk about EMI and RFI, we're not talking about 60 cycle hum that comes from single coil pickups, which this guitar will have. And so we're still going to have 60 cycle hum. But you will see a noticeable reduction in noise if you're in a noisy environment, and environments are all different. But if you're in a room, for instance, that has old fluorescent fixtures with magnetic ballasts, or if there are electric motors in the vicinity, or neon light fixtures, or CB radio transmissions. I mean, there are a million different sources of these things. Then those signals will be kept out of your signal with adequate shielding. One of the problems with shielding a guitar, of course, is that you get these big holes in the box where the pickups come through. The pots are metal and they're sort of shielded in their own right. And so we're not really worried about those. We're not really worried about the switch. But the pickups do poke through. Because of this, some people think that it's a good idea to shield Strat pickups. And there are a couple of ways to do this. One way is to wrap something conductive, like some copper foil or something, around the coil itself, and then connect that foil to ground independent of the two pickup leads. Another way would be to shield the inside of this cavity in some way with foil or with shielding paint, and somehow connect that to ground. But I can tell you that some of the pickup makers, like Lindy Fralin, I know in particular, thinks that this is a bad idea. It will change the tone of the pickup a little bit, and Lindy at least does not feel like it's a desirable thing, and I think probably some other people would agree with that, some other pickup makers. And of course you risk shorting out the coil and other things. So our advice would be just live with that little bit of imperfection in the shielding. Know that it's not going to be a perfect thing, but you will substantially reduce hum that exists as a result of noisy environments, even with the pickups poking through the holes. The other thing we're not going to do with the Strat is we're not going to shield this cavity. Now, some people would say, well, man, the jack, you really definitely need to shield the jack. The problem is that the Strat cavity is tight enough that the tip contact of the jack is really, really close to the walls of the cavity, the floor of the cavity. And I've seen a number of situations where the jack ends up shorting out. It gets shorted to ground if you shield this cavity. So we're going to leave it alone and not worry about it. Now, the way that we shield, a lot of people will use copper foil or aluminum foil, which I find to be very difficult to get nicely into these cavities and have the whole thing looking nice when you're finished. And I've also seen a bunch of guitars come in for repairs over the years where ends of foil have come loose and they're hanging out in the cavity and potentially grounding something or shorting something to ground, and creating intermittent electrical problems. So we use this product. This is made in Canada by MG Chemicals. It's called Super Shield. They make it in this aerosol, and they also make it in a brush-on can, or in a brush-on that you buy in a quart can. This stuff is really noxious, so you want to spray it either outside or in a really well-ventilated environment, because it's pretty nasty to breathe and undoubtedly hazardous to breathe. It uses powdered nickel suspended in some sort of a paint product, and when you spray it in the cavity, it's very viscous, so it stays put on vertical surfaces, but it covers end grain and imperfections in the wood or areas where there was some tear out really, really well, and you end up with a really nice even coating. We spray a couple of coats, and it looks great, it works great. Sometimes in some circles, shielding paint has gotten a bad rap, like somehow it's inferior to foil, but that's not our experience with this product. I have used poor quality paints where they're real thin and they run down the walls and stuff, but with this thing you're going to have really good solid comprehensive shielding, and it's much easier to apply in our experience than foil. So the way we're going to do this is we're going to use this wide low-tack masking tape. This is a product that's made for sign makers. It's a release tape, and it's available undoubtedly on the internet or from any sign making shop. Turn this around so that the roll doesn't hide the action, and I'm going to cut this with a razor knife, and then we'll put another row here. And now I'm just going to go around the perimeter of this with an X-Acto knife and kind of cut it out. So that whole thing took about 5 minutes. And now what we're going to do is we're going to spray in here, but we need to protect, of course, the rest of the body from overspray. And the way we're going to do that is we're going to put a piece of plastic over the body. I'm just going to set it carefully here on this table. I'm going to put this over it, and we're just going to go kind of roughly around the cavity like this, and we're going to cut that part out with scissors. Here's the cutout piece of plastic, and now all we're going to do is use masking tape to tape this tightly around the perimeter so that you know, it protects our body from overspray. And as you can see, there's nothing exacting about this process. It's really rough and crude, which makes it fast. But it's very effective at keeping the overspray off the body, so it works really well. Now, I haven't done this to a body personally in a long time, but I can tell you that, you know, the entire process, when I'm not having to talk about what I'm doing and I just go about doing it, takes me about 15 minutes to completely shield a Strat body from scratch. So that, I don't know how long it's going to take people to do foil or copper tape, but I would think you could easily spend an hour or maybe even a couple of hours. Certainly it's not nearly as fast as this method is. And now we'll just wrap the plastic around the body and tape it up. Again, it's crudely done. We're just trying to keep paint off the rest of the body. So it's basically that simple to prep it. Now we'll just go in there and spray it and we'll be done. We're going to spray it with 2 coats. You definitely want to rotate the body midway so you're getting in the different angles. And then after we're done with that, we'll let it dry for 3 or 4 minutes. This stuff that flashes off really quick, 3 or 4 minutes, you're ready for a second coat. You want it heavy enough that it's covering well, but not so heavy that it's running. And a second coat, and you're done. And then you want to get this stuff off of the body quickly. You don't want to like leave this on overnight because masking tape, even this low tack stuff, can imprint bodies, and you don't want that. So after you get it, spray it. 5 minutes later, pull all of this stuff off, and you're good. Okay, so here we are. We took the thing out back, where we have sort of a little L in the building to try to keep you know, the wind at bay. And we just went around and put several coats on it. And in some of the areas it's probably still a little tacky. I know it's not fully cured, but it dries enough that you can take this stuff off very quickly. It's only been probably 5 minutes since we started spraying, and I'm going to just pull this all off. Oh, I have a little bit of a film build there. I'll just do that. We'll trim that off with a knife later. We've got a slight ridge here as well. A razor knife will just trim that off, but we'll let that cure before we do that. Here's the final product, and you can see little ridges here and there, and these just knock off with your finger. There's nothing to it. Cleans up real nice. It's a very nice uniform coating. It really kind of highlights the grain tear out and stuff. You can really sort of see how imperfect the routing is. I mean, you could get in there and sand it if you want, but Fender doesn't, and most companies don't, although there are a few that do. But this is the easiest and most uniform way that I know to shield the cavity on a Strat or a Tele, and it's a really effective product, and we'll get really good results with this. So we're going to use a gold anodized pickguard on this guitar, and this is a Fender pickguard, and you can see before they anodized it they masked the areas where the pots are going to be and where the switch is going to be. And the reason that they do this is because without the masking, the anodize will prevent conductivity here. So if I put the meter leads here, you can see the meter is staying at infinite resistance. But if I touch between a couple of the masked areas, you see that the meter goes to essentially no resistance. So there's conductivity between these areas. Ground is going to come from the amplifier. It's going to go to the output jack, which is connected to the volume pot. Since the volume pot is mechanically connected to the pickguard, that will ground the pickguard as well. The volume pot's grounded, therefore the pickguard will be grounded. And because of that, we'll have a ground connection to these three components as well. But also that means that our pickguard will, since it's grounded, it will make an effective shield. So this will be the lid of our shielded box, and we'll have effective shielding against EMI and RFI on the guitar as a result. Now we've decided to use Sur pickups on this guitar, and also to use our ToneShaper Next Gen product, our NG03, which will give us some flexibility in terms of setting up the tone controls and that sort of thing. We'll talk a little more about that as we get the installation done. And of course it'll be a solder-free installation with the exception of the tremolo claw, and we will have to solder a wire to the tremolo claw and bring that into the control cavity. So these are the parts for our Stratocaster. We're going to use our Next Gen wiring system, which uses a volume and 2 tone controls and a 5-way switch. Everything connects together with these wired harnesses. We've got pre-wired jack, shield ground wire. This will screw into our control cavity on the shielding paint that we applied, and the other end goes to ground, and that will ground that shielded cavity. And then we'll have a tremolo claw with the ground wire attached. We're using Sur Michael Landau pickups because we love Michael Landau around here, and of course Sur makes great pickups, and we're going to put that on this Fender pickguard, and we'll get going right now. The one thing I will point out, we usually, with these short bushing pots, these are a 1/4 inch long bushing, And they're made for thin materials like mounting to a pick guard as opposed to mounting to a rear routed guitar where they would have to go through the thickness of a body, and you just don't have enough thread length for that. So ordinarily with these short bushing pots we would use these thin lock washers and then mount it to the pick guard, but because this aluminum pick guard is so thin, I'm going to use these slightly thicker lock washers like you would usually see in a rear routed guitar. And these of course are what we use on jacks as well. So this will go together in 5 minutes, and then I'll connect all the wires. That'll take another couple of minutes, and should be, I would think, 10 minutes we'll be done with this. Well, I'll show you our method for installing this NG03 unit on a Strat pickguard. First off, in our instructions, we show the connector cables. There are 3 of them, connecting the 3 pots to the 5-way switch using these designators, J3, J2, J4, P4, P2, P3, and we basically tell you that P3 has to go to J3 and P2 to J2, and these markings are actually on the circuit boards. So you probably, I don't know if you can see it on the camera, but right here it says P4, so that's P4, and here on the switch, right above these little connectors, it says J2, J3, J4, and so those are how you make sure 2 goes to 2 and 3 to 3 and so forth. These little connectors are they're polarity sensitive, but you can only install them one way. Like in this case, this is not going to go this way, it will only go this way, and it just pushes in. You push it in until it's fully seated. Now if you ever have to remove one of these, what you don't want to do is just grab the cable and pull it out. You might get away with that, but you might pull one of the little wires out. The better thing to do, let me flip it this way, maybe be able to see it a little better, is to grab just the top of it like that with a pair of pliers and then just wiggle it out of the housing like that. Now I like these pliers. They're called Duckbill Pliers. Most people are not going to have these laying around, but you've probably got slip joint pliers, and these will work. They're a little more cumbersome to get into tight spaces, but they'll work just fine as well. Once you've got the 3 cables connected, well, and also I should point out that when we do this, we usually put the shortest cable in the middle, and then the next here, and then the longest one here. And this is going to be the volume control, the middle tone control, and the bottom tone control. And then also we find that it's easiest to go ahead and attach the pots to these and then attach everything to the pickguard rather than do it in a different order. So this is the volume pot, and so I will attach the cable to the pots in the same way. This one says tone 1 and this one says tone 2. Now these are identical. You could flip them around. They'll work perfectly well in either orientation. We probably shouldn't have labeled them. We should have just labeled them tone. But you can use them in either orientation, so don't worry about that you might mix them up. And you just plug those in. And once you've got all 3 plugged in, then I attach the 5-way switch to the pickguard first, and then I put the pots in place. We'll get the screws started on this 5-way switch, and I won't get the thing completely tight. I just kind of get it started like that, and then you just get the pots and put them in place. I usually do this one first. Again, because of the thinness of this aluminum pickguard, I'm going to use the thicker lock washers. Lock washer goes inside between the pot and the pickguard, and then on the outside a flat washer and then the nut. So I'll start with the middle tone control and just flip it this way and get the nut and washer on the outside, and just get everything sort of started but not tight. And then this pot goes in place. Put the lock washer again, And just like that, with no soldering, everything's mounted. I'll just tighten these up, I'll put the pickups on, and then we'll just run the pickup wires into the appropriate slots, and here and here on these green terminal blocks, and put the pickguard on the guitar. Okay, so I've got a couple of the pickups mounted, and I'm about to mount the bridge pickup. I thought I'd bring up a couple of things. One is the SIR pickups come with these white covers. We're changing the pickup covers. We need knobs for this pickguard anyway, and so we're going to use Fender knobs. We're going to use a Fender Accessory Kit. We have these in white, but with this color we typically like, with the gold anodized, we typically like this aged white. You can see almost a little bit of a different color between these, and part of the problem we find with plastic is there's often variation in color. And so if we just used these white covers and then Fender white knobs, we might find that the white knobs are yet another sort of different shade of white than these, or they may have a little bit of a different finish. Sometimes these will be sort of matte, where Fender's parts tend to be fairly glossy. So we just use Fender parts. We use their accessory kits. They have them in 6 different colors, and that way you get matching switch tip and the tip for the tremolo arm. You get the volume and tone knobs. You get the pickup covers, and everything matches. The other thing I wanted to point out is that while the SIR pickups come with a screw and a spring, we're not using this hardware. Ordinarily, I like the springs because springs work well. Historically, Fender used latex tubing, and if you look at a guitar from the 50s, these things will be sort of flattened out like a pancake and hard as a rock. They've lost all springiness, and they're almost like petrified. So these things don't really stand the test of time, and they don't work as well as a spring in terms of their springiness. It's harder to compress them, but they're very handy for pre-assembling a pickguard, because you can put the screws in, and the tubing holds the screws in place, and it's very easy then to sort of, you don't need a third hand to try to hold the spring and the screw and the pickup and a screwdriver. But the real reason that we're using them here is because on aluminum pickguards, they're more susceptible to microphonic feedback. And microphonic feedback, in case you're not aware of what that is, it's not the same as musical feedback that comes, that's sort of an intentional thing sometimes when the amp's really hot and you're getting feedback that you can control. Microphonic feedback is not controllable, and it's very harsh sounding. It's like when a microphone squeals. That's where the name comes from, and where everybody suddenly is grabbing their ears because of the microphone squeal. With a metal pickguard, you're going to have more problems with that than with a plastic pickguard, or at least more of a likelihood. So using this latex tubing acts to dampen this metal-to-metal contact between the screw and the pickguard. And with this, of course, you'd have 3 pieces of metal: the pickguard, the screw, and the spring. So with the latex tubing, we're hoping to dampen down the possibility that we're going to get microphonic feedback, and it should be pretty effective. Here is our completed pickguard. We've got the 3 pickups connected into the ToneShaper connector, this green terminal block. We followed the directions on the first page of the instruction manual. It shows the 6 pickup connections coming in here, where they go, and you just stick the wire in to each slot and then come in with the screwdriver and tighten it. You want it snug, pretty snug. You can tug on the wire just to make sure that it's in there good. And once you've done this, then the only other things we need to do are connect our grounds and the jack. Now you can see from the diagram that the jack connects into this little 3-position terminal block, and then this terminal block and the big one have got extra ground slots where you can connect other grounds. So the jack will come in here, and then our two other grounds, our shield ground, which is shown here, and our tremolo claw, which is the bridge ground. Both of these wires will come into the cavity, and they'll connect either into these two empty slots, which are ground slots, or into a ground slot over here. So you've got plenty of ground slots available. The next thing that you need to know is that in order for this unit to work, you have to configure the dip switches that go on it. Now, let's see if that'll stay put. I guess it won't. There are 4 dip switches. There's a 10-position dip switch here, and there are 6, I think, 6-position dip switches on the 3 pots. And those must be configured. By default, they're either all on or all off. I guess they're all on. So you need to go in and configure them for the operation that you want. So since we're using single, 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 we're going to select from this column. The bottom 2 won't apply because that would be just for a single volume, single tone. But in this case, we've got 3 pots. So we're either going to have a volume, tone, tone, and we got 4 different options for that, or we're going to have a volume, tone blender, where this bottom control can be used as a blender. And what that would do, just in case you're unfamiliar with the blender control, is it would allow you to get the neck and bridge pickups on together, or all 3 pickups on together, and with subtle tonal shadings that you would not ordinarily be able to get. So we can choose from any of these 6, and what we're going to do is we're going to set it up for volume, tone, tone, just with a modern Strat wiring. Now this first option, tone 1 is just for the neck pickup and tone 2 for the middle. So you would have volume, neck tone, and middle tone. And this would be a vintage Strat right from 1954. That's how it would have been wired. Now option 3, where we've got a volume control and we've got a neck tone, and then this one is for both the middle and the bridge. That's like a modern Strat, like starting with the American Standard Strat in the mid-80s, where they added the bridge pickup onto this bottom tone control, so the bottom tone control controls either of these. That's the way we're going to wire this. It's probably the most popular wiring still for Stratocasters, although the blender wiring is also very, very popular. Whoever buys this guitar, of course, can pull the pickguard loose, flip a couple of switches, and change it to whatever configuration they want if they want something else. But you have to choose one of these, and you have to configure the dip switches accordingly, or else the thing's not going to work. And we have had that numerous times where people will call and say, well, it's not working, and it turns out that it's just that the switches have not been configured. We give you this little pointed stick to make it easy because they're kind of tiny, so it's easier to get in there and flip switches with this than trying to do it with your fingers. So again, we're going with option 3, and now we've got, in order to configure the switches, we've got a color code. If it's black, it's off. If it's blue, it's on. If it's magenta, it can either be on or off. It depends on whether you want that feature enabled or disabled. And if it's yellow, it means you have to select at least one of those. These are on the 2 tone controls, and these turn on the various capacitors. With a tone control, you must have a capacitor, or else the tone control won't do anything. You'll turn it down and there would be no tonal change. But so at least one of the capacitors needs to be enabled, but you can enable more than one capacitor. You can turn all 4 on if you want, and that will give you, the capacitor values will add together, and the higher the capacitor value, or the capacitance value overall, the more treble will go away as you roll down the tone control. All the way up, it won't have an effect, but as you roll that tone control down, you can either have it be a really pronounced effect, like a Strat from the 50s, or a more subtle, nuanced effect, like a Strat from the 90s. And that's all about what value capacitors you enable or don't enable. on the main switch, which is the one that's on the 5-way switch, we can see that 4, 6, 7, and 10 must be on. Those are blue. 4, 6, 7, and 10. So I'll go in here and I will turn on 4, 6, 7, and 10. That's simple. On the volume control, switches 1, 2, and 4 are optional. They're magenta, so you can turn them on or not. Let's see what they do. 1 drops the pot value to 250K. We're going to enable that because these are single coil pickups. 250K pots would be appropriate, so we're going to make all 3 of these 250K. So 1 will be on. 2 engages a treble bleed, 680 picofarad and 220K resistor in parallel. And then 4 also is a treble bleed. This engages a treble bleed that is 1000 picofarad and 150K resistor. Now let's talk about treble bleed. If you don't have a treble bleed, when you roll down your volume control, you get a little bit of a treble roll off as well. So if you roll the volume down, let's say halfway, you get a tonal shift. And the tonal shift is something that bothers some people and not other people. It'll get a little duller sounding. You lose a little bit of the high end. One way to address that so that you can roll it down halfway and have a more consistent tone is to engage a treble bleed. A treble bleed is, in our case, a resistor and capacitor, which is called an RC network, and an RC network with the 2 components wired in parallel. If you engage them, our experience is that it will address the treble roll-off problem pretty well. But there is not agreement on what value component should be used. You can use any value capacitor, any value resistor, and in fact some people don't even use a resistor, they just use a capacitor. Others use a resistor and capacitor in series. But we find that the most effective is a resistor and capacitor wired in parallel, and that's what we have built into this volume control. And we have 2 options, 2 different values. 680 picofarad and 220K is the value that Fender has used for the last, 15 or 20 years. Whereas a lot of people, if you read on the Les Paul forums, Gibson forums, one of the common values, combinations is 1000 picofarad and 150K resistor. So we give you both. You can enable one or the other or neither. You don't want them both on. So in our case, we'll enable it. We're going to enable the one that's the Fender values, 680 picofarad and 220K. So that's going to have 1 and 2 on. The rest will remain off. Again, 1 drops the volume pot value to 250K. So we'll turn that on. And here's switch 2, enables the treble bleed. Okay, so now the next thing on option 3, tone 1 and tone 2 are identical. The last switch will be off. The 4 middle ones are the capacitor values. We can choose 1 or more. And the first one, as you can see, drops the pot value to 250K, drops the pot value to 250K. Again, remember that these 2 components are identical to each other. They're just labeled differently. So in both cases, we're going to enable switch 1. You see here by the magenta that it's optional. We're going to turn it on, and that will drop the pot value on both of these to 250K. And then for our capacitor value, we're just going to use 0.022 microfarad. That's the capacitor value that Fender used on American Standard Strats from the mid-1980s, basically to date. I mean, it's probably the most common value that Fender has used over the entire production life of Stratocasters. Now this tells us that we've got a 0.01 or 0.010, 0.015, 0.022, and 0.047. So switch 3 is the 022. So we're going to turn on switch 3 on both capacitors. And that's it, we're done. Now again, these capacitor values add together, so if you turned on the 0.010 and the 0.015. If you turned them both on, the values would add and you'd have 0.025. If you turned on the 022 and the 010, you'd have 032. So the values just add, and the higher the value overall, the more pronounced will be your treble roll-off as you roll down the tone control. So that's it. Basically the thing is configured. All we need to do now is mount it on the body and plug our grounds in and our jack in, and we'll be ready to go. And before we mount these other components in here, we're just going to check that this thing will drop on there nice and flush. Here's the thing to consider. We've dressed these wires in the way that Fender did it in the 50s, and the purpose for this central bundle being kind of down the center of the pickup is because Fender does this on their vintage style routing. They put this this channel, so you've got a little bit of depth there for that thickness of the wire bundle to have a place to go. We've seen pickguards where the wires are all over the place, and it makes it a real pain trying to get the thing on the pickguard. If you dress everything like this neatly, these, the cavity ends right about there, where my finger is, the gap. So what you don't want is these things coming out like that. They need to be kind of folded over. And we'll just check this and see if the pickguard basically drops into place. And it does. It goes right on, so we know that we're not going to have any problems once we get all of the things connected. And so the next thing we'll do is we'll go ahead and attach our claw wire and our claw actually, and the shield ground, and we'll connect both of those to ground as well as our jack leads. Now for our shield ground wire, we could install it in a couple of different places. Fender has done it. I've seen them where they've done it on the wall of the cavity like this, sort of in here. I've seen them do it on the floor of the cavity. I think what we'll do is we'll put it right here in the floor of this cavity. The wire will come out and sort of miss that channel, but we will need to bend this a little flatter so that it's not so high profile. This screw we can just drive in. We don't need to make a pilot hole. We're going into face grain, so it will go right in with no problem. And we'll strip a little wire from our two grounds. Now again, we've got 4 different slots for ground here. The top one on this is for the jack's white wire, but these 2 bottom ones are both grounds. And these 2 here are both grounds. So we've got 4 ground slots. We've only got 3 ground wires to connect, and it doesn't matter which goes into which. It does matter, of course, where the jack's white wire goes. That has to go into the right place. Now we just drop the pickguard onto the guitar. We shouldn't have any interference because we tested it before we added those additional components, and now we just screw it on. Okay, at this point I've screwed on the pickguard and I've screwed on the bridge. I thought the camera was rolling, but it wasn't as I did those operations, but obviously you know how to screw the pickguard on. You do need to be a little careful that there are no wires that are getting trapped between the body and the pickguard. If it doesn't go all the way down flat, it's just a wire somewhere, and you can use a flashlight, kind of look, underneath the edge, see where the wire is, what's causing the interference, and then you can, use something skinny like this underneath the pickguard to kind of push any wires down in the cavity, or pull the pickguard loose and, manipulate the wires so that the thing goes down flat and screw it in place. Now the next thing that I did is I screwed the bridge on. This particular bridge is a Callahan bridge, and it has a unique feature. It has the wide screw spacing that Fender used in the 50s and 60s, and on current reissue guitars. This screw spacing is from the center of the outer measuring or mounting screw to the center of the other outer mounting screw is 2 7/32 of an inch. So if you measure from the center of this hole to the center of this hole, it's 2 7/32 of an inch. On certain Fender guitars, they use a narrower screw spacing. Callahan makes two different bridges that will fit this particular screw spacing, which is the vintage screw spacing. They make a true vintage bridge, which has the screw spacing, but also has the same string spacing, which is 2 7/32 from the center of the E to the center of the E. And on some guitars, you'll find that puts the two E strings near the edges of the fretboard in such a way that sometimes you can, it's kind of problematic. You're always pulling the high E string off the edge of the fretboard. In the 80s, when they came out with the American Standard model, of course they went to the two-post tremolo, but they also changed the string spacing from 2 7/32 to 2 1/16, which is like going basically from where my thumbnail is to where my thumbnail is. So it's almost 1/8 of an inch. That brought the two E strings in slightly. It overall narrowed the string spacing from string to string and sort of alleviated that problem. Now on some Strats, the wider string spacing is not a problem. My main guitar is a Stratocaster. It has the wide true vintage bridge with the wide string spacing, not a problem at all. But I had another guitar that I played for years. It was a 71 Strat, and that guitar had a real problem with the E strings being very close to the edges of the fretboard. None of my friends could play the guitar. They always said, "How do you play this thing?" Constantly pulling the high E off the edge of the fretboard. I just kind of acclimated to it over time, but in any case, we've gone with Callahan's kind of conversion bridge, which gives you the wider screw spacing of the vintage style, so it screws right onto the vintage body, but it's got the narrower string spacing of the American Standard guitar. And since so many people now are familiar with the American Standard and play American Standard and its derivatives, the guitar's been in production since the mid-1980s. They've sold millions of them. So we decided to go with that narrower string spacing. Many people will find it to be very comfortable and familiar, and of course it also will make sure that we don't have a problem with the E strings being at the edges of the fretboard. The other thing is that when I screwed this bridge on, basically I took the two outer screws and one at a time I screwed it down until I saw the rear edge of the tremolo just start to lift away from the body. When the screw goes down, the screw head goes down, it'll push the front edge down and the rear edge up. And as soon as you see that lifting, then you back off the screw so the bridge settles back against the body, and then a little bit more, back it off a little bit more, and leave it. So the two outer screws are just 10 or 15 thousandths away from the underside of the screw head to the top of the tremolo plate, so that they don't bind. You don't get any binding in the movement of this tremolo. And you can see that I can go fully from stop to stop. It's hitting the wood inside, which is stopping it. Here it's against the body, and here it's hitting the wood. So I can go fully from within its range of motion, and there's no binding at all. And then the other 4 screws I run down, but I don't seat them. I leave them maybe a 1/16 of an inch of a gap underneath the heads, and that way they can't provide any sort of constriction of movement, but they still provide a bearing surface so that as the strings try to pull the bridge this way, you've got 6 screws resisting that force. And now the bridge is mounted, the body's done. I still need to tighten these 2 holes or screws, which I have not done yet. So we'll do that very quickly. And now we'll put our springs on, and we're going to use 3 springs. We'll string this guitar with 10 to 46 strings, and my experience is that that 3 springs will give us about the proper amount of adjustment. And we'll sort of fan them out like this. So this is another handy use of the Duckbill Pliers. I will grab this spring right like that, put it here, and now I can push with my thumb like that and insert the spring with full control. And the body's ready. Now we just screw the neck on. Now I do have wax, little bits of wax in here and there on the body, and I can do it with a dry paper towel, as I said earlier, or we just use a little naphtha on there, and the naphtha will quickly wipe that wax away, and then we buff it with a dry paper towel. But I'm going to use wax on these screws, so I might as well hold up, and we'll worry about the wax after we're done with everything. We're ready to screw the neck on. We're going to put a Callahan neck plate. This is a stainless steel neck plate. It's a little thicker than the brass neck plate that Fender uses, which are their chrome-plated brass. This is stainless steel, and it's got a 5-digit serial number that's just a random number. But we're going to put that on this guitar, and we've got stainless steel screws. I've taken the time to put some wax in the threads, and we're ready to go. So the first thing to do will be to just get the neck down in the neck pocket. And again, we're going to be careful with this. let me pull this back out. I'm going to try to wiggle the neck this way as it goes in. Of course, it won't move much at all, but just that, as the little bit of motion that I can get will help it to go down in as I'm pressing here. Because it is a snug fit on this guitar, but it does go in there, and there we go. I'm going to bring it up this way, and we'll get started with the screws. Now, anyone who's ever set up a floating tremolo knows what a pain it is to set one up. So what we need to do is take the tremolo float out of the equation. So we've got the springs in the back. The claw is pulled more this way than it will end up. So it's putting force on in this direction that's going to endeavor to hold the rear edge of the tremolo down. So we're going to force it up, and we're going to put this spacer underneath it, and this will give us approximately the angle that we're going to finish with. This bridge was designed to float. If you look at the original patent drawings from 1953, you'll see that it does in fact show the bridge with the rear edge lifted off the body. Now, some people don't want to use a tremolo, and they set the guitar up with the bridge flat against the body. But in this one, we're going to set it up floating, which allows you to do those nice, like Stevie Ray Vaughan kind of chord sweetening moves. I particularly like these tuners. Basically, you just cut the string a little bit long, put the end down in the hole in the center, give it a kind of a hard bend, and tune it up. I've heard people who have said that they have trouble with getting the string to really grab in there, but I never do. They usually just hold very well, and it's quick and easy, and then you don't have any string ends hanging out there that can poke you in your fingertips. One thing to note is that with the floating bridge, you need to set it up with the gauge of strings that you're going to be using. This guitar, as I say, will be set up with 10 to 46. If someone wants it set up with 9 to 42, for example, they will have to set it up again for that string gauge. The reason for that is because the strings are pulling on the top of the bridge and the springs are pulling on the bottom of the bridge. And you have to equalize the force so that the bridge is balanced or floating in between those two forces. If you go to a different string gauge, you'll be exerting a different amount of force on the top and it'll upset the balance. So you have to set up a floating tremolo for the gauge of strings that you're going to be using. And again, if you take the floating feature out of the bridge during the setup, it makes the setup way easier, because if the bridge is allowed to move while you're doing the setup, every little adjustment that you make has a consequence with the position of the bridge, and you end up just chasing your tail. Well, as I would expect, given that the neck and body are both from Fender, everything lines up properly, and that is a relief.